Okay, you guys, so we're going to start 9.1 today, the algebra of functions. One of the main things we're going to go over is composition of functions, but let's just kind of work our way towards that. So add, subtract, multiply, and divide functions. So in the previous section, the previous two sections, I believe, or chapters, we discussed what a function was and we worked with functions. So now we're going to learn kind of some properties of functions and using our algebraic techniques with functions, okay? So here's something that you want to definitely memorize and understand, that algebra of functions works like this. So let f and g be functions. New functions from f and g are defined as below. So what we can do is we can say this notation here, f plus g of x. F plus g of x means f of x plus g of x. F minus g of x means f of x minus g of x. So again, I don't want you to think you're distributing the x, because that's not what's happening here. You're not doing the distributive property. This is just a, I don't want to say a formula, but that's basically what it is. But it's how we define adding and subtracting of functions, okay? If you're multiplying and you have this notation, you say f times g of x, that means find f of x, and you multiply it by g of x. And likewise for division, f divided by g of x, we take f of x and we divide it by g of x, okay? And of course, g of x cannot be 0. So let's do a little practice with that. So when I say let's do part A, B, C, and D. So the first one will be part A and B in this first page. And then on the next page, we'll do, for this one, we'll do A and B. And on the next page, we'll do C and D. So if I want to do f plus g of x, I know that this means f of x plus g of x. But I know that f of x is 4x plus 3, right? Right here, they tell me f of x is 4x plus 3. And here they tell me g of x is x squared. So this becomes plus x squared. And if I want to write it in descending order, this would be x squared plus 4x plus 3. And this would be f plus g of x, okay? Now you guys take a minute, do the same thing, but do f minus g of x. All right, so hopefully you wrote this, f of x minus g of x. So this would become 4x plus 3 minus x squared. So this would become negative x squared plus 4x plus 3. And that would be what f minus g of x would be. Not so bad, right? Let's go over here to multiplying now. So I know that f times g of x would be f of x times g of x. So this means that f of x is 4x plus 3, and g of x is x squared. And again, all I'm doing is I'm doing f of x times g of x, right? So then this will become 4x cubed plus 3x squared. Nice and clean, okay? This one, we know that f of x would be 4x plus 3, and we know g of x would become x squared. And that is all there is to it. Not so bad. Now, if we wanted, we could split this and we could say, well, this is 4x over x squared plus 3 over x squared. So this is really 4 over x plus 3 over x squared. So it really depends on how they want their solution, depending on the problem and how they ask for it. But this is an acceptable answer as well. It just really depends on how the problem's worded. Okay, so let's take a look now at composition of functions. So we can also combine functions through a function composition. A function composition uses the output from the first function as the input to the second function. So I often think of this as a function embedded within another function, okay? So the composition of functions, f and g, is written like this. So this is the notation you will see. You'll see this little open circle right here. That does not mean multiply. That means f composed with g. Okay, and I prefer writing it like this. You'll see it like this, and then I'll instantly translate it when I go to do the work into this, to f of g of x. So I like that much better than saying f composed with g of x. So this means the value of x is first substituted into the function g, then the value that results from the function g is inputted to the function f. So this sounds like a lot, but all it really means is you take one function and you plug it into the other function. Okay, or if you know the value, then you take that value and you plug it into the other function. So here we have two functions, f of x equals 2x minus 5, and g of x equals x squared plus 1, okay? I want to first find f of g of 2, okay? So they give me this, they say f composed with g of 2, and I don't like that, so I'm going to write it like this, f of g of 2. So what I do is I say, well, what's g of 2? Okay, well, here's g of x, okay? So then I'm going to say, well, g of x is x squared plus 1, right? So when I plug a 2 in here, I plug a 2 there, this becomes 2 squared plus 4. Oops, 2 squared plus 1. So that would be 5. So what I'm really saying is f of 5. And what would f of 5 be? Now, f is 2x minus 5. So now I'm going to do 2 times x, but instead of x, I'm going to use 5 minus 5. So we get 10 minus 5, which is 5. A lot of 5s floating around in that problem. So the way I like to think of it is I like to think of it like this. Now, alternatively, what you can do when you do that. Now, again, I think it's easier when they give you a number. What if I had just said, find f of composed with g of x. So in order to do that, I would have said, well, let me rewrite this as f of g of x. But we know that g of x is worth x squared plus 1. So what this means is you're now going to take x squared plus 1 and you're going to plug it in where x is in the f of x. So that means I will now have 2, but instead of x, I'm going to write x squared plus 1 minus 5. So this will become 2x squared plus 2 minus 5. So this will become 2x squared minus 3. Okay. Now, here's the thing. When they say to do, let me see here. When they say to do f of g of 2, right? Well, I just found f of g of x. So technically, I could now say, well, let's see here. I could say f of g of 2 equals 2 times 2 squared minus 3. And that would be what? 8 minus 3, which is 5. So notice that answer is the same as this answer over here. And that's because they're both doing the same thing. But in this particular problem, they told us from the beginning that we're going to plug 2 in. Notice here, because I found f of g of x, that means I found it for all time. So now I could do another number. I could do f of g of 3. And I could just very quickly plug it into here. And this would be 2 times 9 minus 3. And that would be what? 18 minus 3 would be 15. So that means f of g of 3 would be 15. So once you found f of g of x, now you can plug any number you want into it. But if they give you the number, I have to say it's probably easier to say, if you want to find this, just first find g of 2, then whatever you get from that, plug that into f. So this is why I think of it more as, I think in your book, they say the rightmost function. I think of it as whatever's the innermost function. So what function is embedded within the other function? That's how I think of it. So now let's go the other way. Let's go g of f of 2, okay? So we'll do this one in green. G of f of 2 means first find f of 2, right? So f of 2, if I plug 2 into here, right? So I'm going to take 2 and plug it into there. That would be 4 minus 5 is negative 1, right? So that means I'm now finding g of negative 1. Now, if I take g of negative 1, well, here's g, plug negative 1 in there. I get negative 1 squared plus 1 equals 2. So that's how you can do it. And you see that it matters which was the innermost function, whether it was the g of 2 or the f of 2. It changes the outcome of the answer. So just make sure that you're paying attention to which way the problem is written, and always go with the innermost function first and then work your way outside. or as the book says, the function that's furthest to the right. So if you have f of g of 2, notice which function is further right. G is further to the right, so you first find g of 2 and then plug that answer into f, or that value, evaluate f with that number. Okay, so I'm going to pause the video and let you guys try these two on your own. So take a minute and try. Oh, wait, hold on. Did I already do this one? No, this is new. So this one doesn't give you a value. They just want you to find f of g of x, or f composed with g of x, and g composed of f of x. Okay, so give those two a shot, pause the video, and then when you come back, I'll walk you through it. Okay, so hopefully you guys made your way through this. So the first thing I do is I rewrite this as f, and then g of x I know is x squared. So now that means I'm going to take x squared and I'm going to plug it into f. So that means it's 4, but instead of x, I now have x squared plus 3. So this is just 4x squared plus 3. Nice and clean, okay? Okay, now let's look at the next one. Now we go the other way. G of, now what is f of x? So here's now the inner function, and f of x is 4x plus 3. So then that means I have to take 4x plus 3 and plug it in for g of x, or in for the x. So this will become 4x plus 3 quantity squared. So that's what, 16x squared. Oops, it's a big 16x squared plus 24x plus 9, I guess. So that when you FOIL it out, you get that. Okay. So yeah, that would be the two. Hopefully you guys did okay on that. All right. So, and again, they want you to notice that f of g of x is not the same as g of f of x. If they are in fact the same, that means we'll learn in the next section that they are inverses of each other. So f is an inverse of g, or g is an inverse of f, depending if you get the same answer. So if I had got 4x squared plus 3 for both of these, that would mean there's a special relationship between f of x and g of x. Okay, but we'll talk about that in the next chapter. Okay, so there's something else. Let me see how much more we got. Oh, it's almost the last two. So there's something else they like you to do is they sometimes, just to kind of get your brain to think backwards a little bit, we like to practice, well, what if I knew the composition? What would be the building blocks for that composition? So let's say I give you the final answer, and then I'd want to know what is f and what is g and in which order. So here they say if f of x is equal to 7x and g of x is equal to x minus 4 and h of x is equal to square root of x, write each function as a composition with f, g, or h. So what I'm going to do first is I'm going to say, well, if I wanted to write big F of x, and I say that it's worth the square root of x minus 4, okay? So that means that I want to use two of these to create big F of x. So I see that g of x is worth x minus 4 and h of x has a square root. And notice here, I have a square root and I have an x minus 4. So the inner function has to be the x minus 4 and the outer function has to be the square root. So what I can do is I can say, well, let's see here. We want the outer function, which is h. So we're going to say h composed with g of x. So remember, that means h of g of x. So now let's write this out. And again, that's what they're showing you down here. I just want to show you guys how my thinking process goes. So I'm just thinking of, well, if g of x is x minus 4, that would mean this is h of x minus 4. But what's h? H is the square root of x, so it's the square root, and then I put x minus 4 instead. So this is the same as this. Now, another way to look at it, here's where it kind of is something you got to be more careful of. So what if I told you that big H of x is worth, oh, I don't know, the square root of x plus 1, okay? And then I ask you to find f of x and g of x such that f composed with g of x equals big H. of x, okay? So that means, what could f of x and g of x be? Well, that means that f of x is the outer function, so I'm going to say it has to be the square root of x, okay? And g of x is the inner function, so I'm going to say it has to be x plus 1. So that means, what if I do f of g of x with these made up ones? I'm just making this up. Well, I would get f of x plus 1, and that equals the square root of x plus 1, right? Because you would take this, you would take x plus 1 and you would plug it right there, okay? But here's the problem. I could do another one. I could say, what if f of x was worth the square root of x minus 3, and g of x was worth x plus 4, okay? So now let's try this. Let's do f of g of x, okay? So I'm going to take f of x plus 4, and I'm going to say this is the square root. And now instead of this x here, I'm going to use this x plus 4, right? So this is going to become x plus 4 minus 3, right? So this will become the square root of x plus 1, which once again is h of x. So this could be f of x and this could be g of x, or this could be f of x and this could be g of x. How many different ways could I do that? I could do that an infinite amount of times. I could just keep manipulating it and making it so it always will end up to be x plus 1, and just changing the way everything works a little. So that's why there's an infinite amount of ways I could write it. So when the homework is working, they're going to normally tell you the ones they want you to use, because otherwise there's an infinite amount of answers. So just understand there's an infinite number of ways to do it. However, for our, for the homework and stuff, normally they will give you the ones they want you to work with. Okay. Yeah, I think that's it. You guys can do this one on your own. If you need any help with this, feel free to contact me, or show up at a meeting and let me know if you need any help. All right, thanks you guys, and I will see you in the next meeting.